using the zero exponent rule of exponents. The zero exponent rule of exponents states that for any non-zero real number a, the zero exponent rule of exponents states that if you have a base that's raised to the power of 0, it's going to equal 1. So in example number 4, we're going to use the zero exponent rule. We're going to simplify each expression using the zero exponent rule of exponents. So use the zero exponent and other rules to simplify each expression. So in part A, we have c, a base of c to the power of 3 divided by the base of c to the power of 3. So when we're dividing with the same base, that means we need to subtract our exponents. So we're going to have the base of c to the power of 3 minus 3. Well, 3 minus 3 gives you 0, so we have a base of c to the 0. Now again, going back to that rule, we have a base that has a power of 0, which then becomes a value of 1. If you come back and look up here, well, c to the third divided by c to the third would simplify to 1. So that's just giving you a proven way to know that your answer is going to be 1. Next, we have a constant, -3, times the variable x to the power of 5 divided by x to the 5th power. So the -3 is factored out, and it's going to be times x to the 5th divided by x to the 5th because they have the same base. So since they have the same base, we're going to get -3 times the base of x to the power of 5 minus 5. Now keep in mind here that the -3 doesn't have the exponent to 0. It's the base of x because 5 minus 5 is 0. So we have -3 times x to the 0 power, and we know that x to the 0 power is 1. So -3 times 1 gives you -3. For part C, we have a base of j squared times k to the power of 4. And in the denominator, we have j squared times k times j squared times k to the power of 3. So what that means is, in the denominator, we need to simplify that first. And if you notice here that there's an exponent of 1 for the first term. So in our numerator, it stays the same, j squared k to the power of 4. In the denominator, it becomes j squared k. Since they're the same base and we're multiplying them, that means we have to add our exponents. We get 1 plus 3. So when we add 1 plus 3 in a denominator, it now becomes j squared k to the power of 4. So now we're dividing with the same base, which means we need to subtract our exponents. So we have the base of j squared k to the power of 4 minus 4, which then becomes a power of 0. Regardless of what the base is, if it has a power of 0, then that means that the answer is going to be 1. Next, part D. We have 5 times the base rs squared to the power of 2 divided by the base of rs squared to the power of 2. So the 5 remains a constant. We have the same base and we're dividing them, which means we need to subtract our exponents, which is 2 minus 2. So we're going to get 5 times rs squared to the power of 0, and that's going to equal 1. So 5 times 1 is going to give you the value of 5.